Okay, so last meeting we discussed about exact differential equations. So when we say exact, so exact means that if the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x. Now, we are going to discuss non-exact DE. Meaning this equation does not apply, or this is unequal. All right, so how do you solve for differential equations that are non-exact? So we use the method. So when we have a non-exact DE, we make it exact by using an integrating factor. All right. All right. So non-exact DEs. So how do we get the integrating factor? So for example, for these types of equation, so we have equation 1. So we have 1 over n times the partial derivative of m with respect to y minus the partial derivative of n with respect to x will be equal to a function in terms of only x. So if you have an equation like that, then the integrating factor should be e raised to the integral of f of x dx. All right. Now, if you have an equation, or you can manipulate the equation into this one, so we have 1 over m times the partial derivative of m with respect to y minus the partial derivative of n with respect to x is equal to a function which is only in terms of y. Then the integral factor is e raised to the negative integral of f of y dy. All right. Now, so if we multiply, so by multiplying the integrating factor to the equation, makes non-exact DE become exact. And then by having an exact DE, we can now solve its solution. All right. So let's have an example. Okay, we have an example right here. We have y minus xy dx plus x dy is equal to 0. Now from this equation, we have this as your m and this as your n. Now let's look at it. Let's test if it's really non-exact. So what is the test for exactness? We have partial derivative of m with respect to y would be equal to the partial derivative of n with respect to x. So let's do this first. Alright, so we have the partial derivative of m with respect to y is equal to the partial derivative with respect to y of this equation. So we have y minus xy. So the partial derivative should be so what is the partial derivative of y with respect to y? That is 1 minus, so we treat all the other variables as constants, so we have x. And what is the partial derivative of y? That is again 1, so that would be equal to 1 minus x. How about the other one? So we have partial derivative of n with respect to x. So what is n? We have x. And so that would be, what is the partial derivative of x with respect to x? That is 1. So basically 1 minus x is not equal to 1. Therefore, the DE is non-exact. Now we need to get the integrating factor. Alright? So how do you get the integrating factor again? So let's try the first equation. So the first equation we have, remembering, we have 1 over n times the partial derivative of m with respect to y minus the partial derivative of n with respect to x is equal to a function with only terms of x or a constant, right? So any function in terms of x or a constant, then you use what the IF should be, e raised to the integral of the function in terms of x dx. So now let's check. Alright, so what is n? So n is basically x. So we have 1 over x. So what is the partial derivative of m? So we got that earlier. So this one, we have 1 minus x minus, so what is the partial derivative of n with respect to x? So we also have that one. We had that earlier, so that is 1. So is it equal to a function in terms of x or a constant? So let's see. So you have 1 over x. So 1 minus 1, that is negative x. Now, so that becomes negative 1 is equal to f of x. Now, this is a constant. So how do we know if we use the first equation or the second equation? So let's check. Okay, let's check. Let's do the second equation. So the second equation was 1 over m times the partial derivative of m with respect to y minus the partial derivative of n with respect to x is equal to f of y. Right? So let's try that. So what is m? So m is you have 1 over y minus xy. That is your m. So we already have this part here that is negative x. Is that equal to a function in terms of y or a constant? Okay, so that should be equal to negative x over 1 minus xy. So that is that a function in terms of y only? So it is not a function of y only, or the variable y only, or a constant. Therefore, we still use the equation 1. All right. Now, using the equation 1, so your integrating factor becomes what? That is e to the integral of the f of x dx, which is e to the integral of, what is f of x? So we already have that here. So negative 1 dx. Therefore, e, what is the integral of negative 1? That is negative x. So that is your integral factor. Now what do we do with the integral factor? So we multiply it. So multiplying to the equation, so we have, so what is the equation? What was the equation? That was, oh, sorry. That was y minus xy dx plus x dy. Let me fix that. All right. So we multiply everything by the integral factor. So the integral factor was e negative x. And so what happens is that, so that becomes e to the negative x times y minus xy dx plus x e to the negative x dy is equal to 0. This becomes your new equation. All right. Okay, let's try to distribute this. We have e, sorry. Okay, let's use this as our new equation. So this becomes our new equation. All right. Now this is your new m, and this is your new n. Now, let's test for exactness, if this is really exact. All right. So what is the test for exactness? We have partial derivative of m with respect to y is equal to the partial derivative of n with respect to x. Now, what is the partial derivative of m with respect to y? So what is m? We have e to the negative x y minus e to the negative x x y. Sorry about that. Let me fix that. All right. Okay. Now, we differentiate with respect to y. So we treat all the others as constants. All right, so we can differentiate the first term. So we have e. What is the integral of the first term? We have e to the negative x. Or what is the integral of y? It's basically 1. Then, what is the integral of, we copy the constants. What is the integral of y? It's still 1. So let's make it clear. Right. How about the second one? So the integral of n with respect to x. So n is basically what? With respect, so integrate with respect to x. So we have x e to the negative x. So what is this? This is product rule when we integrate. Product rule. What is the product rule? So the integral, the derivative of uv is what? V du plus u dv. So this is the integral rule. Product rule. All right. Okay. So what is v? You have x and du. What is the derivative of e to the negative x is still basically negative e to the negative x. And what is u? You have e to the negative x. And what is dv, or the integral of x? Derivative of x, that is basically 1. So simplifying, we have negative x e to the negative x plus e to the negative x, or rewriting or rearranging, we have e to the negative x minus x e to the negative x. So basically, both are equal. All right, and therefore, the equation is now exact. Now, how do we solve for the DE for exact equations? How do we solve it? Okay. So solving for exact equations, so we have the partial of f with respect to x is equal to the function of m in terms of x and y, and we also have the partial of m with f with respect to y is equal to n in terms of x and y. All right, so let's rewrite our equation. First equation, so we have e to the negative x y minus x y e to the negative x dx plus x e to the negative x dy is equal to 0. So let's do the first formula. So we have the integral of f, the partial derivative of f with respect to x. So where is your m? Your m is this one, the first term. So we have y e to the negative x minus x y e to the negative x. So basically, how do we get f? So basically, f is the solution to the equation, okay? Where f is the solution to the dE, right? So we have y e to the negative x minus x y e to the negative x. Okay. Now, how do we solve this? How do we get f? So we integrate both sides. So how do we integrate both sides? So with respect to x, so we have f. Okay, integrating the first, or we can distribute the integral. So we have y e to the negative x d partial of x minus integral x y e to the negative x partial of x. All right, so let's do the first term. We have, so we can take out y, integral of e to the negative x partial of x. In the second term, so let's take out y, the integral of x e to the negative x dx. And so let's integrate the first term. So on the integral of e to the negative x, so that's basically negative e to the negative x. So how about this one? How do we get the integral of x e to the negative x dx? So that is basically what? Integration by parts. So what does the integration by parts mean? So let u be x and du be dx. And let dv be e to the negative x dx and v be, so what is the integral or the differential integral, sorry, what is the integral of e to the negative x? So that is still basically negative e to the negative x. So that's how you get the v. All right, so it's the antiderivative of dv. And it is said that the integral of u dv is equal to uv minus integral of v du. So let's do that. And let's copy the equation. First part. Okay. So what is u? U is x. And what is v? So there's negative e to the negative x minus the integral of what is v? So we have the negative e to the negative x dx. Okay, du is the x. So let's simplify. Okay, what is the integral of, or let's take out the negative sign first. Okay, so what is the integral of e to the negative x? So basically, the integral of e to the negative x is the, so we take down negative 1, or that's basically negative 1. That is negative e to the negative x plus q y, q of y, right? So distributing, we have y e to the negative y e to the negative x minus, or negative y times positive negative, it's positive xy e to the negative x minus, or plus y e to the negative x plus, so q of y times y, it's still q of y. So as you can see, there are like terms. So we have y times e to the negative x and negative y e to the negative x. So that cancels out. So your f is what? X y e to the negative x plus q. Okay. So that's your first. How about the second one? All right. So what is the second one? So the partial of f with respect to y is equal to n. Okay. So what is n? Partial of f with respect to y. N is x e to the negative x. All right. Now that becomes f. Partial of f is equal to the x e to the negative x partial of y. Integrating both sides integrating both sides with respect to y. So that's basically f is equal to, so you treat this as constants. So we have x e negative x. So what is the integral of dy? So that is basically y. So we have, rearranging, we have x y e to the negative x. Now we forgot the r of x. R of x. Now how do we get r of x? So both are equal to f, and so we have x y e to the negative x plus q in terms of y is equal to x y e to the negative e to the negative x plus r of x. Okay, that cancels out, and so what is left is q y is equal to r of x. So what does this mean? Okay, so there are no terms there. As you can see, there are no terms in terms of x only or y only. So we have q of y is equal to, it's safe to say that q of y is equal to 0 and r of x is equal to 0. Therefore, what is the solution? So that is basically f is equal to x y e to the negative x. Sorry, let's move that. So that our f is actually c. Okay, let's not forget the constant. So let's simplify a little bit more. So we have c so we did multiply both sides by 1 over e to the negative x. So that is c over e to the negative x times xy, or simply cex to the power of x times xy. So this is now the solution to the equation. Alright, so that is how you make non-exact DEs exact by using the integrating factor.